The surface of Mars is drier than the Sahara and colder than Antarctica. Because the atmosphere is so thin, liquid water cannot exist. It evaporates instantly. If you stepped out onto this dirt without a pressure suit, you would instantly begin to freeze, boil, and suffocate all at the same time. On top of that, you would absorb a heavy dose of radiation because Mars has almost nothing to block the raw nuclear energy pouring out of our sun. These hazards mean the months-long journey to Mars is far too dangerous for humans to simply arrive and start building. We cannot launch a crew millions of miles out into the void and expect them to fend for themselves on an inhospitable frontier. Before human boots ever touch the ground, we have to send mechanical avatars. We need an army of metal scouts to conquer the terrain and map the hazards, eventually building the infrastructure we need to survive. Our attempt to conquer this planet actually started decades ago. In 1971, the Soviet Union launched the Mars 3 mission, which became the first man-made object to achieve a soft touchdown on the planet's surface. Tucked inside was a tiny 4.5-kilogram metal box called Prop M, humanity's first Mars rover. It used a pair of wide skis to slowly step forward, tethered to the main lander by a 15-meter power cable. But the Prop M was never fully deployed. After just 14 seconds of transmitting a single scrambled image, the signal went completely dead. The total failure of Mars 3 proved that the Martian environment destroys delicate hardware. To successfully establish a foothold, engineers would have to forge a relentless step-by-step evolution of robotic hardware built specifically to endure extreme punishment. When NASA's Viking landers arrived in the 1970s, they delivered a harsh truth. Mars is not a smooth, sandy desert. The terrain is littered with small chunks of jagged rock. That rugged landscape put Mars exploration on hold for 2 decades, until the Pathfinder mission delivered Sojourner in 1997. This little vehicle was roughly the size and weight of a microwave oven. Driving a remote-controlled car millions of miles away meant NASA needed a design that absolutely would not get stuck. This schematic illustrates the mechanical solution they invented, the rocker-bogie suspension system. It features a long arm in the front and a shorter arm in the back, linking the wheels to the main body. This geometry allows each wheel to pivot independently, keeping all 6 wheels in constant contact with the ground. Because of this, the rover could safely crawl over obstacles a third of its own size. With the suspension proven, NASA scaled up. The Mars exploration rovers, Spirit and Opportunity, were the size of golf carts. They used the exact same 6-wheel drive system, but the extra size allowed them to carry a fully mobile array of scientific cameras and spectrometers. The current milestone in this wheeled lineage is Curiosity and its twin, Perseverance. At the size of crossover SUVs, these machines require a beefier version of the rocker-bogie system to traverse the landscape, and instead of solar panels, they draw electricity from radioisotope thermoelectric generators, onboard systems that convert the heat from decaying plutonium into power. These machines have covered dozens of miles and operated for over a decade, but eventually every wheeled vehicle meets a steep hill or a deep crater it simply cannot climb. To take planetary exploration further, the Vanguard had to leave the ground. Mars has no roads, and its uneven, mountainous terrain strictly limits how far a rover can travel in a single day. To map the planet effectively, we had to solve a critical physical constraint. The atmosphere on Mars has less than 1% the density of the air at sea level on Earth. Finding an equivalent air density here would require climbing to an altitude of 87,000 feet, twice as high as any helicopter has ever flown. This vector diagram shows how NASA's Ingenuity helicopter compensates for that thin air. It uses 2 oversized rotor blades constructed from ultra-lightweight foam and carbon fiber. To generate enough lift, these blades have to spin at double the RPM required for a helicopter on Earth. You'll notice the 2 propellers spin in opposite directions. The torque generated by one blade is instantly canceled out by the other, keeping the drone perfectly stable in flight without the need for a traditional tail rotor. Originally planned for just 5 test flights, Ingenuity completed 72. It spent over 2 hours in the Martian air. That success has already prompted NASA to design heavy-lift hexacopters capable of carrying up to 5 kilograms of scientific payload across the landscape. The ability to fly allows the Vanguard to bypass the obstacles that stopped every previous mission. With the landscape mapped in 3 dimensions, the focus can shift from finding where to build to actually starting the work. For humans to survive on arrival, SpaceX plans to deploy fleets of Starship landers, each carrying up to 150 tons of cargo. The earliest shifts will serve as heavy drop pods, releasing dozens of autonomous AI-powered workers onto the surface. Humanoid machines, like the Tesla Optimus, are designed to perform the physical labor of laying down infrastructure in temperatures that would kill a human crew. Their first target is buried underground: water ice. Small mining rigs will dig up this ice so it can be processed in automated treatment plants on the surface. This creates a stockpile of drinkable water, and by breaking the water molecules apart, the robots will generate breathable oxygen. In this chemical flowchart, you can see the second vital task. Rocket fuel is too heavy to carry for a return trip to Earth. Instead, the robots will pull carbon dioxide straight out of the thin Martian atmosphere, mix it with the hydrogen stripped from the water ice, and synthesize it into methane. The robots will manufacture the fuel required to send empty ships home. Next comes shelter. The earliest permanent structures won't be glass spheres. Instead, worker robots will pump liquid water into large, donut-shaped inflatable molds to create highly durable, translucent ice domes. Frozen water is an incredible insulator, and it acts as an effective shield against solar radiation while still letting natural light shine through. For larger industrial buildings, the Vanguard will manufacture biocrete. By extracting urea from the waste products of the first arriving human colonists and mixing it with the toxic Martian rock dust, they can forge a construction material that is actually stronger than standard concrete used on Earth. These machines will manufacture an entirely artificial biosphere out of frozen dirt, captured carbon, and human waste. By the year 2050, the flat plains of Arcadia, resting under the shadow of the towering Olympus Mons, could house a permanent city of over 1 million people. Sustaining a population of 1 million residents requires extreme agricultural engineering. Martian soil is laced with toxic chemicals called perchlorates, salts that contain chlorine, the same substance used to kill bacteria in swimming pools. To grow crops, automated facilities will have to chemically wash thousands of tons of dirt and fertilize it using human waste to create viable farmland. Every system, from the biocrete walls to the methane fuel plants, serves a single goal. A Mars colony only succeeds if it achieves strict self-sustainability. If the supply ships from Earth ever permanently stop launching, for whatever reason, the city on Mars has to survive on its own. If humanity does cement its future as a multi-planet species, it will be because a decades-long lineage of machines flew, drove, and mined their way across a dead world, sacrificing themselves to permanently pave the way. Progress almost always requires us to abandon the weak, disposable systems of the past and choose better, highly engineered solutions. That holds true whether we are terraforming a planet or just trying to get a clean shave. Henson Shaving is a Canadian company manufacturing razors with incredibly precise aerospace tolerances. By exposing the blade just 0.0013 inches, they eliminate the flex and chatter that causes skin irritation. It is a permanent upgrade to an outdated, disposable routine. Click the link below and use code THESPACERACE to get 100 blades for free. And to keep tracking the mechanical vanguard expanding across our solar system, make sure you subscribe to the